Here we shall go with the other new topic, that is orthogonal trajectories in Cartesian coordinates. Here you can expect one question from this topic. A curve which cuts every member of a given family of curves at a right angle is an orthogonal trajectory of the given family of curves. So here orthogonal nothing but 90 degrees. For example, if we take two curves, one curve cuts the another curve. So the given family of curves, one equation depicts the different family of curves. For example, for circle we have x square plus y square is equals to 1 of radius, which is of radius 1. So here you can take the values of x and y differently, and the family of curves will be different. And in parabola, y square is equals to 4ax, and in that way also we can take the different curves, so will be there for each values of x and y. So those all comes under the family of curves. So the curve which cuts every member of a given family of curves, one family of curve, and the another curve which cuts the every member at right angle. The curve which is cutting the family of curves of the right angle, then that is called as an orthogonal trajectory of the given family of curves. Let's see the working rule of this. To find the family of orthogonal trajectories in Cartesian form, we had to find out the family of orthogonal trajectories, and this is in Cartesian form. So we have to assume that it is a function of x, y and constant variables. It means the function consists of x, y variables and constant c, and this is equals to 0. We have to assume that equation as 1, and it will be given in the question. Be the equation of given family of curves in Cartesian form. So let this equation 1 be the family of curves in Cartesian form. Now in this, first we have to eliminate the c from 1. So from this equation we have to eliminate the constants. Whatever the constants are there in the equation, we have to eliminate those. After eliminating the constant, we have to obtain the differential equation. So after this we have to differentiate with respect to x. We have to differentiate this function with respect to x, then that will be in the form of x, y and y dash. Y dash nothing but dy by dx. So here we are differentiating with respect to x. When we are differentiating with respect to x, we get extra term dy by dx, and dy by dx nothing but y dash. So here in the place of constant we will get the extra term, that is y dash, because we are eliminating c here. Then that function we have to assume it as equation number 2. Now after getting this, we have to replace the dy by dx by minus dx by dy. So after find outing the differentiation, we get the differential equation. There we will have the dy by dx. Now in this place of dy by dx, we have to substitute the minus dx by dy. So replace dy by dx by minus dx by dy in equation number 2. Then the differential equation of the family of orthogonal trajectories. So here is nothing but we will replace the dy by dx by minus dx by dy. Then we will get one equation in terms of x, y and minus dx by dy variables. We have to assume that equation as equation number 3. Now after getting this, we have to solve the equation 3 to get the equation of the family of orthogonal trajectories of 1. Now we have to integrate this equation. After replacing the dy by dx by minus dx by dy, we have to integrate this equation. Solving the equation 3 nothing but we have to integrate it, then we will get the family of orthogonal trajectories of the equation 1. Let's solve few problems on this topic. Then here first question, find the orthogonal trajectories of the family of curve, that is y is equals to ax. So they given the equation y is equals to ax. This is the family of curves. The given family of curve is y is equals to ax, and we have to assume this equation as 1. Now we have to differentiate this equation, that is differentiate 1 with respect to x. When we differentiate here, we get dy by dx is equals to constant is a, and x differentiation with respect to x is 1. So we get dy by dx is equals to a. Now let this be as equation number 2. So from this equation 1, so in this equation 2 we have to eliminate the constant c. Now to eliminate this constant, this is a constant here a. Now to eliminate this, from the equation 1 we can write y is equals to ax can be written as a is equals to 1 by x. So here this can be written as ax is equals to y, and from this a is equals to x can be sent to the right hand side, it goes into the denominator, then we get a is equals to 1 y by x. Now a is equals to y by x, substitute in equation 2. So when we substitute here, we get dy by dx is equals to y by x. So dy by dx is equals to y by x. Now we have to replace the dy by dx with dx by minus dx by dy. Now replace here, we get minus dx by dy is equals to y by x. Now when we cross multiply here, we get minus x dx is equals to y dy. Now we have to integrate it on the both sides. When we integrate here, we get minus integration of x dx is equals to integration of y dy plus c. So integrating here, then minus integration of x is x square by 2 is equals to integration of y is y square by 2 plus c. Now it can be written as x square plus 2 x square by 2 plus y square by 2 plus c is equals to 0 as the orthogonal trajectory of the given family of curve. Then second question, find the orthogonal trajectories of the family of parabola through origin and foci on y-axis. So here the family of parabola through origin, nothing but we have the family of curves, that is y square is equals to 4ax and x square is equals to 4ay. For we have the 4 different types of parabolas. One is of turning right side and open upward, open downward and open leftwards. So for these 3 we have the different equations of the parabola. So for this we have the y square is equals to 4ax, and for this we have x square is equals to 4ay, and for the open downwards we have the x square is equals to minus 4ay, and open leftward we have the y square is equals to minus 4ax. So given that family of parabola passing through origin and foci on the x-axis. So we have the foci on the x-axis. So for this foci lie on the x-axis, and for this focus lie on the y-axis, and for this it lies on the negative y-axis, and for this it lies on the negative x-axis. So they given that foci on y-axis, they didn't mention whether it is positive or negative, but when they didn't mention here, we have to take it as the positive, and the foci lies on the positive x-axis. So positive x-axis nothing but x square is equals to 4ay will be the curve. So here they didn't mention the curve in the question, we have to get it by the statement. So the equation is x square is equals to 4ay, and let it be as equation number 1. Now we have to differentiate this equation 1 with respect to x. So when we differentiate here, we get 2x. Here x square differentiation is 2x, and we are differentiating with respect to x. So dx by dx will be 1. Then here on the right hand side, 4a is constant. Y differentiation with respect to x is dy by dx, and let this be as equation number 2. Now we have to eliminate the a from this equation, and from this equation a we can take a is equals to x square by 4ay, and we have to substitute in this equation. So that is nothing but replace, we have to eliminate the constant a. Now from 1 we can take the a is equals to x square by 4y, we have to substitute in the equation 2. So 2x is equals to 4 of x square by 4y into dy by dx. Now here 4 will be cancelled, and here 1x will be cancelled. Then remaining is 2 is equals to x by y dy by dx. Now dy by dx is equals to 2 into here x by y dy by dx is equals to 2. Now dy by dx is equals to 2 into, send this x by y to the right hand side, it becomes y by x. So that is dy by dx is equals to 2y by x. Now we have to replace the dy by dx with minus dx by dy. Now substitute here, we get minus dx by dy is equals to 2y by x. Now cross multiply here, you get minus x dx is equals to 2y dy. Now we have to solve this equation, that is integrating on both sides. We get minus integration of x dx is equals to 2 integration of y dy plus c, minus integration of x is x square by 2 is equals to 2 into integration of y is y square by 2 plus c. Now x square by 2c, send this all term, send this to y square to the right hand side, then we get it will be cancelled. Send this y square to the left hand side, we get minus y square, but here when we multiply with minus it becomes plus, and this c can be sent to the left hand side and it goes into the denominator. You get x square by 2c plus y square by c is equals to 1. Then let's see the third question. Show that the system of a rectangular hyperbola x square minus y square is equals to a square and xy is equals to c square are mutually orthogonal trajectories. So we have to prove that these two rectangular hyperbolas, these two equations are mutually orthogonal. We have to prove that. So first take this equation. Now equation x square minus y square is equals to a square be as equation number 1. Now we have to differentiate this equation 1 with respect to x. We get x square differentiation is 2x and minus y square differentiation is 2y into y differentiation is dy by dx, since we are differentiating with respect to x, and that equals to constant differentiation is 0. Then we get 2 of x, 2 common from this, 2 of x minus y into dy by dx is equals to 0. So x minus y dy by dx is equals to 2 will be sent to the right hand side, it multiplies with 0 and it becomes 0. So we get send this y dy x to the right hand side, then you get x is equals to y dx by y dy by dx. Then here it can be written as dy by dx is equals to x by y. Now we have to replace the dy by dx with the minus dx by dy. When we replace here, we get minus dx by dy is equals to x by y. Now minus dx by dy is equals to x by y. From this we have to cross multiply it. Cross multiplying nothing but when these x come to the left hand side, it becomes minus 1 by x, and send this dy to the right hand side, it becomes dy by y, nothing but 1 by y into dy. So here so to get more clear, I'll write here minus dx by 1 into 1 by dy is equals to x by 1 into 1 by y. Now dx by dy, send this x by 1 to the left hand side. When you send here, it becomes 1, x by 1 becomes 1 by x, and here minus dx is equals to 1 by y. Send this minus 1 by dy to the right hand side. 1 by dy becomes dy by 1, nothing but 1 by y into dy. So we have to integrate it on both sides. On integrating, we get minus integration of 1 by x dx is equals to integration of 1 by y dy plus c. So integration of 1 by x is log x. So minus log x is equals to integration of 1 by y is log y plus here also the log c. So c or log c, whatever it is, because it is a constant, we can write it any way. Now minus log of, send this log y to the left hand side, it becomes minus log y. So minus log y minus minus log x minus log y. From the both terms we can take minus common. When we take minus common, minus of log x plus log y is equals to log c. So minus log x plus log y can be written as log xy. We have the formula that equals to log c. Now log will be cancelled on both sides, then we get minus xy is equals to c. So minus you send that side also, it becomes a constant. Now constant can be written even as constant square also, still it will be a constant. So xy is equals to c square. It has proved that both the system of equations are the orthogonal. Now let's see the last problem on this topic. Find the orthogonal trajectories of the one parameter family of curves e power x plus e power minus y is equals to c. So the equation e power x plus e power minus y is equals to c be as equation number 1. Now differentiate this equation number 1 with respect to x. So e power x differentiation is e power x, and here e power minus y. E power minus y we are differentiating here. So minus 1 this will be the minus e power minus y, and since we are differentiating with respect to x, we get dy by dx, and that equals to 0. Then here minus dy by dx is equals to, send this e power x to the right hand side, it becomes minus e power x divided by, and here it is multiplying with dy by dx. When you send this to the left hand side, it goes into the denominator. It becomes e power minus y, 1 by e power minus y. So minus dy by dx is equals to minus e power x by e power minus y. Now dy by dx on both sides minus will be cancelled. Then dy by dx is equals to e power x by e power minus y. Now we have to replace this dy by dx with minus dx by dy. When you replace here, we get minus dx by dy is equals to e power x by e power minus y. Now we have to solve this. Then we can send the e power x to the left hand side. It becomes 1 by e power x dx is equals to 1 by e power minus y dy. Now we have to integrate it on both sides. So integration of minus 1 by e power x dx is equals to integration of 1 by e power minus y dy by dx, or dy plus c. Now write this minus outside of the integration, that is minus integration of 1 by e power x can be written as e power minus x to dx is equals to integration of 1 by e power minus y can be written as e power y dy plus c. Now minus of e power minus x integration is e power minus x by minus 1 constant. By the formula we have integration of e power ax dx is equals to we get e power ax by the constant a. So here the constant is minus 1. So that's why I have written minus 1 in the denominator, is equals to e power y by, here constant is 1. So divided by 1 plus c. Then minus will get cancel. Then you get e power minus x is equals to e power y plus c. You can leave it like this, or you can even write e power y minus e power minus x is equals to c. So this is a equation. So these problems are very important. Practice these problems. You can expect one question on this topic.